reflections across the x and y axis. So let's take a look at what a reflection is. A reflection or mirror image is a transformation that flips. Notice the capital FL in the word reflection. It flips a figure over a given line called the line of reflection. Notice in both examples, each point and its corresponding image point are equal distance from the line of reflection. So here's the blue line of reflection. On the left side, this is 3 units away, and on the right side, it is 3 units away. That's what that means. This concept creates the flipping look with a reflection. Now, as you can see in this video, or this slide, some of the original points when you reflect is going to end up in the same spot. So you have the original figure A, which is over here, this rectangle. Now, if I were to reflect this point here that's on the blue line, well, it's not going to go anywhere. So the coordinate of that point is going to end up being the same, and same with the one below. And that's okay. But each of the other points, you can see this point over here and this point over here, each of them, that's 1, 2, 3, 4 spaces away from the line of reflection. So 1, 2, 3, 4 spaces away on the opposite side of the line of reflection. Okay, now we're going to look at when we reflect over the x or y axis, just focusing on one specific point. So first off, we're going to look at the reflection across the y-axis, which is in red. You can see here we have our point. If I look at the right point as the original, it's 2, 4. It reflected over the y-axis, which is bold in red, and it is 2 spaces away from that line of reflection. Now, if you count on the other side, it is 1, 2 units away on the opposite side. If you compare the coordinates for the x's, now if you notice, the x's are the same digit but opposite values. So one of them's a -2, the other one's a +2. Then if I look at the y coordinates, they're exactly the same. So what you can say is when you're reflecting over the y's will stay the same, the y coordinate value, and the x coordinates become the opposite of what they were. So if it started out as a -2, the opposite of a -2 would mean it became a +2. And similar on the reflection across the x-axis. So if this is my point 3, 2, I'm going to count 1, 2 spaces from my line of reflection, and it is also 2 places away from that line of reflection on the other side. Now if I compare, let's see, the x coordinate, they're both the same, and then the y coordinates are the opposite. So when I reflected over the x-axis, the x's stayed exactly how they were, and the y values became the opposites. So again, when you're reflecting over the y coordinates will stay the same, and the x values become the opposites. When you reflect over the x-axis, the x values stay the same, and the y's become the opposite. Moving on to the rules. So what do the rules look like? As always, your rules always start with the xy, and for a reflection over the y-axis, remember I said the y will stay the same, the y's stay the same, the x's become the opposite. Now on the reflection across the x-axis, remember the x's will stay the same and the y's become the opposite, and you represent the opposite using the negative sign. Negative means the opposite. So those are your rules. All right, so let's take a look how we can use our rules. So We want to find the image coordinates for A prime given A, which is at 2, 6, and it is going to get reflected across the y-axis. So remember, here's my original point. The y will stay the same. The x becomes the opposite because we're reflecting over the y, so the y stays the same. The x becomes the opposite. So if the original y was 6, the image point is going to stay at 6 for the y, and the x coordinate was a 2, it's going to become the opposite of -2. All right, for our last example, now we are going to take triangle GHI, and it's going to get reflected across the x-axis. We only care to find the coordinates of I prime. Okay, so we're going to go across the x-axis and only focus on I. So here's I. The coordinates of I, you can see I have written down here, is 6, -2. Now, since we're reflecting over the x-axis, the x will stay the same. So you see here, I kept the x coordinate as 6, and the y coordinate of -2 is going to become the opposite and turn into a +2. So your image point I prime is 6, +2. And so there's your reflection. So don't forget, you're reflecting over the x-axis, the x coordinate stays the same, the y becomes the opposite, and if you're reflecting over the y-axis, the y coordinate stays the same, and the x becomes the opposite. Good luck.